Welcome to another exercise for the workbook Statistics. This time with an exercise focusing on t-test for coefficients or the f-test for overall model quality. So let's have a look at the exercise. Here we have, in the context of a regression, the data for 79 participants is considered. It resulted in a line that describes the relation between the expenditures for their summer holiday in euro, so that's the dependent variable y, depending on the gender, that's variable x1, with 1 being equal to female and thereby 0 being equal to male, the age, x2, and the income in euros, x3. The result is as follows. Then a coefficient of determination of r squared equal to 0.41 has been calculated. Our task: use a suitable test to check for a margin of error of 5% whether the relation is significant. So what we have to do here is simply conduct a normal f-test. For the f-test, we have the following formula. Since we already have the r squared, the main part is actually already done. Because for the f-test, we simply divide the r squared by the number of x variables, by number of independent variables. That's here x1, 2, and 3, so 3 independent variables. Then we have 1 minus r squared, that's 0.59, divided by n minus k minus 1. N is the number of observations. So here we had 79 observations, minus k, that's the 3, minus 1, gives us 75. So if we then calculate this double fraction, we get as a value 17.3729. So that's our test statistic for the f-test, meaning we still need a reference value, a reference statistic. For the standard f-test, we get this as with f, k, n minus k minus 1, 1 minus alpha. Well, the k we have here at 3, the n minus k minus 1 we have here as 75, and finally we have 1 minus alpha. Alpha, that's the margin of error, and as we recall in the text it said margin of error should be 5%. So here we calculate 1 minus 5% or minus 0.05, giving us 0.95. Then we turn to the respective table for the f distribution and look up exactly this value, which is stated as 2.7266. So that's more or less everything we have to do in preparation, because for the test itself we only compare test and reference statistic, seeing here that the test statistic is much larger than the reference statistic, which means our H0 hypothesis can be rejected. H0 in the context of an f-test means the model has no explanatory power. So since it can be rejected, here it means the model has significant explanatory power. So well, that's then everything there is on this exercise, on this task. I hope you enjoyed this short session. I say goodbye and see you next time.